Day 278 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 137, single number 2. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's see what the question says. Question says, given an integer array nums where every element appears 3 times except for one, which appears exactly once, find the single element and return it. You must implement a solution with a linear runtime complexity and use only constant extra space. All right, y'all, sounds simple enough, but let's go ahead and look at these examples just so we can make sure that we are doing what it is that they want us to do. So in example 1, we have the input nums equals an array of integers 2, 2, 3, and 2. The output is 3. The output is 3 because 3 is the only element in here that appears exactly once, right? All the other ones are going to appear 3 times except for 1. And in this case, the 2's appear 3 times, but we want the element that appears once, which in this case is 3. So that's why the output is 3. So let's go and look at example 2 just to really bring it home. In example 2, we have the input nums equals an array of integers 0, 1, 0, 1, 0, 1, and 99. This time the output is 99. Same thing. Output is 99 because 99 is the only element that appears once. As you can see, so the 1 appears 3 times. It appears here, here, and here, and the zeros appear 3 times as well, here, here, and here, but we want the element that appears once, which is 99, so thus that's why the output is 99. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution's not that difficult at all. We're in the bit part of the top interview 150 questions, so we're going to be doing some bit manipulation here. So I hope y'all are excited about that. Now let's get into it. First thing we're going to do, we are going to need to declare a variable. We could call it ones, and we could set that equal to 0, and this is going to keep track of the bits that have appeared once. Then we're going to declare another variable. We call this twos, set that equal to 0 as well, and this is going to keep track of bits that appear twice. Simple enough, right? So now let's start our for loop. We're going to say for n nums. Then we're going to open up the brackets, right? So first thing we need to do is we need to update ones with bits that have appeared once so far. So in order to do that, we are going to say ones equals ones, this little up caret right here, and then we're going to do the and sign. Then we're going to do this little squiggly line sign, which is the bitwise not. So this is the bitwise not, and this is the bitwise or, this is the bitwise and. So then we are going to use, after we use the bitwise not, we are going to say twos, right? So if y'all not aware what this does, this right here is the bitwise OR operator, and it compares the corresponding bits of two integers. If the bits are different, then the result will be 1, and if the bits are the same, then the result will be 0. Then this right here, this sign, this little squiggly line right here, that's the bitwise not operator, and it inverts all bits of a number, right? So if every 1 will become a 0, and every 0 will become a 1. Now that we understand that, now we have to update the twos. So we're going to update the twos with bits that have appeared twice so far, right? So this updates the bits that have appeared once so far. Now we need to update the bits that have appeared twice so far. So in order to do that, we are going to say twos equals twos. Then we're going to do the up sign, bitwise OR operator. Then we're going to say n and. Then we're going to do, once again, bitwise not operator, and then we are going to say ones, right? So this right here is going to toggle bits where n has a 1, right? And this right here, this is going to ensure that bits already counted once are not included again. And the same thing up here, this right here is going to ensure that bits already counted twice are not included, right? So this bits that are included once are not included. This bits that are included twice are not included. Now, after processing, all the number ones contains the bits of that number, right? After we processing, right, all this right here, ones, is going to contain the bits of the number that we're looking for, and that appeared only once, since bits that appear 3 times get reset. So we could just come right here and we can say return ones, because this ones is what's going to hold the number for us. So boom, that should be all she wrote, y'all. Let's go ahead and run it. Make sure it runs like it's supposed to. Ooh, and it's accepted, y'all. So let's go ahead and submit it. Make sure it stays accepted after we submit it. Let's see. Fingers crossed. Fingers crossed. Oh, there you go. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. Y'all already know those are the numbers I like to see, y'all. We're just going to keep going on our LeetCode journey. We're not going to let anybody dismantle our progress, y'all. And even if they do, we still going to keep going, y'all. We're not going to let anybody stop us from accomplishing what we're trying to accomplish. So I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.